Ladies and gentlemen, thank you for watching. My name is Mark Anderson for Kellogg Community College, and we'll be looking today at solving some non-linear systems of equations. Though they may have one or two linear parts, we're all going to see some parabolas, hyperbolas, circles, and some non-linear systems in them, and we're going to see if and when they intersect. We are going to kind of like tap into some older knowledge. If you have done substitution, elimination, or use the transitive property, these three videos will kind of cover each one of those when it's most appropriate. Just as a beginning to all of these videos, we're going to use substitution when we can easily isolate one of our variables. We will use elimination when the powers are all the same among variables in the problem between x and y, usually two variables for two equations. And we will use the transitive property when we see equations set equal to the same variable. So in this video, we are going to focus on substitution. And substitution is when you can easily isolate a variable and then substitute that into the other equation. Because what we see in this equation is we have a parabola and we have a straight line. The top equation represents a straight line. It can be rewritten as y equals mx plus b form. And the problem down here is a parabola that opens up to the right. Now, what you're looking at is, in this picture here, is you're actually looking at a solution of that problem. So this is, in actuality, the answers to the problem through graphing. But you have to imagine that on the test and the homework, there will be no pictures. And I also do not recommend that you try graphing these because being human, if you're off ever so slightly on the graph, you will find that you will unfortunately not intersect at the perfect points, and it will honestly take longer to graph these and convert them to the correct format than you might think. So what we're going to do is practice for these next two problems the substitution method, because we can in either one of these problems easily isolate a variable. In fact, I'm going to easily isolate this y in the problem. And so I'm going to start off with 2x minus y equals 4, and I'm going to get the y by itself. I'm going to subtract 2x from both sides. This will essentially give me on the left-hand side a negative y, and on the right-hand side we have a negative 2x plus 4. Then we're going to divide everything by negative 1. By dividing everything by negative 1, we now have y equals positive 2x minus 4. So now my y is equal to 2x minus 4. Now this blue 2x minus 4 is now going to go inside of this problem up here. So I'm going to put that 2x minus 4 inside of the y of the other equation. Now in doing so, what that is going to give me is one solitary equation with just the variable x. And what this will allow me to do is actually solve for x. So now I'm going to write 2x minus 4 twice because it is 2x minus 4 quantity squared, which means I'm going to have to FOIL this and then collect all my terms to one side of the equation and then solve for x. So here I have 2x and 2x, which makes a total of 4x squared for my first cable of FOIL. Then 2x times negative 4, which is negative 8x. Then go under here, negative 8x. Go under here, positive 16. And that's equal to 4x. So I'm going to subtract the 4x from both sides because that will then give me a 0 on the right-hand side here. And what's left is a trinomial of 4x squared minus 20x plus 16. Now, a couple different options. Like you might say to yourself, well, I'll just factor this tricky trinomial, or I'll use the Pythagorean theorem, or the quadratic formula. But in fact, the best thing to do is to divide everything by 4. Which is also similar to factoring out of 4 and then dividing both sides by 4. Because now if I divide everything by 4, the problem gets smaller and it is still factorable. And it's just a little bit easier to factor now that we've reduced everything by 4 and now have a first term of 1. So the two numbers that multiply to make 4 and add to make negative 5 is x is equal to, x minus 4 and x minus 1. And so if I solve for x there, I have x is equal to 4 and x is equal to 1. Because either x minus 4 is equal to 0 or x minus 1 is equal to 0. Add 4 to both sides, add 1 to both sides. My answers are x is equal to 4 or x is equal to 1. Now what I'm about to do is I'm about to plug those back into my equation and figure out what my y variable is. So now I know that my x is equal to 4 and my x is equal to 1. So I can plug it into the top equation or this middle equation or this bottom equation, and these two equations will then give me what my value of y should be. Now what's kind of interesting is I can actually plug it back into this blue equation that we circled, and that would give me the easiest answer for y. Because now if I go y equals 2 times 4, that's where I'm plugging that in there, minus 4, you can see that this is going to be 8 minus 4, which is 4. So x is 4, y is 4, that's the point 4, comma 4. Now you'll note that that is actually this point right up here. Again, with the picture, you kind of know where your answers are, but you're not going to have that on the test. Now I'm going to plug the 1 into that equation, this y equals 2x minus 4. So now it's y equals 2 times 1 minus 4. So now I have y is equal to 2 minus 4, which is negative 2. So now that I know my y is equal to negative 2, I got 1 comma negative 2. And look, there it is. Y is equal to 1 comma, or y is equal to negative 2. So your points are 1 comma negative 2 and 4 comma 4. And again, boy, this would be really great if you had the pictures on the test, but you know, you don't. So this is just a really good example though, when you take a look at them. All right, let's do our last problem of the video. And you can see that this definitely lands in the, hey, we should probably use substitution, because one of our problems is already isolated. So we're going to put that x plus 4 into the y of the first equation. So we didn't have to do any manipulation to isolate one of these variables. So let us go and do that. I'm going to put a little square by it because we're plugging this into the y squared right there, since this was y. So now I have x squared plus the quantity of x plus 4 squared is equal to 4. So x squared is equal to, or x squared plus x plus 4 is equal to 4. Now I'm going to FOIL that out, so I've got x squared plus the first cable, x squared, plus these two cables here, which is going to be 4x plus 4x, and then finally the 16 equals 4. So I'm going to subtract 4 from both sides, because that will give me on the right-hand side here a 0. And now I'm going to do a lot of collecting of like terms. So we have x squared, we have 2x squared, because 1x and 1x make 2x. 8x plus 12 equals 0. Well, great thing to do here is divide everything by 2. Divide everything by 2. So x squared plus 4x plus 6 is equal to 0. And now we have to factor that. Now, what two numbers multiply to make 6 and add to make 4? Yeah, 1 and 6 doesn't make 4, and 2 and 3 doesn't make 4. Well, maybe it's a decimal, right? Maybe it's a decimal that does that. So what we'll do is use the quadratic formula. A is equal to 1, B is equal to 4, and C is equal to 6. So this is negative b plus or minus the square root of b squared, that's 4 squared, minus 4 times 1 times 6. And if I do that, that gives me a negative 8 all over 2 times a, which is 2 times 1, which is 2. Now, at this moment, I'm going to stop. And the reason why I'm going to stop is because the square root of negative 8 is imaginary. See, imaginary. That's right. So this square root of negative 8 is imaginary, because you can break up the square root of 8 as the square root of 4, square root of 2, and square root of negative 1, so 2 square root of 2i. And at that moment, we're looking for an x value that has some imaginary number in it. And yeah, and I didn't even talk about this piece sitting out here, but it doesn't matter. It has an imaginary number in it, so no solution. But that's pretty obvious if you take a look at the picture, right? Like this right here, y equals x plus 4 is a straight line, starts at 4 and moves up 1 over 1. And this is a circle here with radius 2, right? So there's your x squared plus y squared equals 4. There is no intersection. There is no solution. So my key to this is probably realizing that it wasn't factorable. But, because it could have been a decimal factorization, I went forth and checked using the quadratic formula. But look at the picture. The picture has no intersection. And it is unfortunate that you won't have the picture, or you won't have the You won't have this on the homework or test, but again, this might have been easier for you to actually draw and see that than do all of the algebra, but you can see how it kind of lines up here. Well, thank you for watching this first video. Be sure to watch the other two videos where I talk about the other two methods, such as elimination and the transitive property, when dealing with these nonlinear systems of equations. All right, thank you very much for watching.